Good morning. Today we have to start a very important chapter of C, which is very important if you consider data structure, if you consider C++ or anything else. So 100% we are going to get the crystal clear concept in this chapter, which is known as pointer. Okay, let us start with pointer. Actually, if I declare a variable like this, int num1, then what the system will do? The system will allocate a memory for this num1 because this entire statement is known as declaration of the variable. And what is the meaning of declaration? Declaration means memory allocation. And that particular memory allocation is known as address of operator, address of variable. Okay. As for example, if I want, I can write 90. Why? Because it is a normal variable. That's why it can contain integer value because the data type is int. If I want to get the address of this num1, it is possible with the help of this address operator. It is known as address operator. It is known as address operator. What we can do with this address? If we want, we can know the address with the help of this. If I want, I can use the address of variable to fetch the value of the variable. Both the things are possible. But as far as this address is concerned, you cannot do two things. Number one, you cannot change the address of the variable. Once it is allocated by the system, you have to accept it. Number two, you cannot compel the system to store the variable at a specific location. Both these two things are not possible. But yes, 100%, if you want, you can get the address with the help of this address operator, and also if you want, you can use this address to fetch the value or to manipulate the value of the variable. How? That is the topic of pointer. That is a sub-subject of pointer that we have to see 100%. Now, to understand this address operator, I want to use this particular program. Here I have written include stu.s that you are knowing int ab char ch equal to r, a90, b75. From here to here, just what we have done, we have declared two int variable, one character variable, and we have assigned the value also. A equal to 90, b equal to 75. Here this %d is required to print the value of a. Printing means what? Printing means this printf statement is a request. We are requesting that I want to fetch the value. I want to fetch the value from the location of A. That's why we are writing %d A. But if I want to know the address, I can write this operator, address operator A. But here I am using %u. In some compiler, %d is also okay. But I think you are knowing this one, that %u means unsigned int. Unsigned int means we are getting more range in positive side. If you want any clarification or any crystal clear concept, you can go through with my tutorial, which is also given, and in my tutorial data type, where you can get this %d, %u, %f, %lf, all things are given there. Okay. Then again, What is the meaning of this percent A and B? The value of B, is 75, but again it is an address. What is this? Percent C, again value, but percent U. Please concentrate here now. Here also percent U, here also percent U. Why? Because we are printing the address, and address is integer, and the nature of both the address without the consideration of data type, the nature will be same. That's why I am using percent %u, and here also percent %u. I think now we understand the purpose of this address operator. Address operator is used to fetch the value of the location. Although it is fixed that when I print A, I will get 90. When I print B, I will get 75. When I will print CH, I will get R. But what is the value of this address operator of A, या फिर address of B, या or address of CH? Actually here the system will decide what is the location of these variables, and maybe if in the same machine I will execute it again and again, I can get different location for the same variable, because it is the responsibility of system, it is not the responsibility of programmer. That is, or we can say that it is the duty of system to allocate the memory of the variable. That's why we cannot challenge that this variable will be stored at this particular location. It is not possible at all. It will give by the system. I am not explaining these two. First I want to execute it, compile. Here if you are getting this error 0 and warning 0, it means I can execute it. Okay, then go and execute. You are getting 90 is the value of A, this is the location. 75, it is the location of B, and what is this R, and it is the location of CH, which I have already done it. Okay, what is this then? Actually the address operator is not capable to fetch the value of a constant value like this. Address of 1 to 5 cannot be fetched. If I omit this comment line and try to compile it, you will get an error here. It means address operator is not capable to fetch the location of a constant value. Again, if I will delete this comment symbol here and try to compile it, again it is an error. It means this address operator is not capable to fetch the address of any expression. Both these two things are very, very important. First one, that the address operator is not capable to fetch the constant value, or it is not capable to fetch the address of an expression. Okay, so now I want to move further here. If I declare a variable like this, int asterisk n1, what is the difference between this num1 and this n1? Here we have declared only data type and variable name, but here I have written data type with asterisk and a variable name. Actually, as soon as we put this asterisk with any variable name at the time of declaration, that variable becomes a pointer. Pointer means a variable which is defined to point another variable. What is the meaning of this point is, because just we have discussed that as soon as we declare a variable, I will get a location. If I want to declare a variable which can store the location or address of another variable, we have to declare the variable as a pointer variable. Like this, if I write now n1 equal to, just we have discussed that we have to use this address operator. Now it is correct. Here num1 is 90, but here n1 equal to ampersand num1. If you consider the general syntax that how we can declare a pointer variable, then I can say that the general syntax is data type asterisk and variable name. This asterisk is special because we are writing it only to make this variable as a pointer variable. Okay, that's why I have written this int asterisk n1 like this. If I write this float asterisk n, what is the difference between these two? What is the difference between these two? Actually, here if you write n1, it means n1 can hold. Please listen carefully. N1 can hold the address of a variable of type int. Here n2 can point a variable of type float. Actually, this int and float is used only to indicate the type of the variable which is to be pointed by the pointer. Again I am telling you, like this, if I am writing int asterisk n1, it means n1 is a pointer variable which can hold the address of int variable. Again, if I am writing float asterisk n2, it means n2 is a pointer variable which can hold the address of a float variable. Similarly, if you write char and asterisk, maybe it is something C. Then what is the meaning of this asterisk C means? Means the C will store the memory location of a char variable. Okay. To understand this one clearly, again we will go for another program which I have written here only to show the character of this pointer variable. Then please see line by line. Int a normal variable, asterisk b a pointer variable. It means b can hold the address of int variable. Here char ch normal variable, asterisk c is a pointer variable. It means again c can hold the address of character variable. Float f1 asterisk f, again f1 is a normal variable and f is a pointer variable which can hold the address of float variable. Now a equal to 90, no problem here. Here you can say we are going to get 90. B equal to address of a. Here what is the value? That we cannot give the answer because the location is decided by the system, as we have discussed also in our last program. Then ch equal to a, again a, but here again address of ch. F1 equal to 90.75, then F1 and again the address. Okay. Then my question is very genuine question, that which one is the bigger one, B, C or F? Because B is holding the address of int variable, C is holding the address of character variable and F is holding the address of float variable. No, both are same. Why? Because in C it is very easy to discuss. Why? Because to print B also I am using %u, to print C also I am using %u and F also %u. As we have told that the nature of address is always a constant value and the nature is always integer. It means B, C and F both are same. If we consider the character, if we consider the nature, if we consider any characteristic, there is no any difference except the type of the variable pointed by them. because this int, char and float, these indicates the nature of variable, not the nature of b, c and f. B, C and F, if we can say that the nature of B, C, F are pointer type, it is 100% correct, because both threes are pointer, 100% pointer, and the the nature is integer. Only they are different in the case of nature of the variable pointed by them. So from now, if someone will ask that which one is bigger one, greater one, B, C or F, our answer should be that both are same. Only the difference is the nature of variable pointed by the point. I think now there should not be any confusion. Okay. If you have any doubt, it is my request also that you can contact with me on the given WhatsApp number, and I will try to give you the answer as early as possible. Okay. Now, now I want to discuss one another thing, which is known as dereferencing of pointer. What is the meaning of this? Just first I want to write one simple like this n3. Here I have written n3 equal to address of num1. I think from here to here, now we are understanding. Now we are understanding that this int num1, it is a normal variable which holds 90. It is a pointer variable which holds the address of num1. Why? Because n3 is capable to hold the address of int. Actually, if I print, what is this? If I write num1, what is the value, sir? 90. That is value of num1. Okay. If I am writing n3, n3 means what? Value of n3. What is this? Value of n3. But what is the value of n3 is, what is this? Address of num. Then, if I write asterisk n3, actually as soon as you write asterisk n3, the system will try to fetch the value of the variable pointed by the pointer. It means what is this? It means because it holds the address of num1, so it will give you the value of, what is that? Num1, and that is 90. Now please listen carefully. Actually, if you write this asterisk at the time of declaration of the variable, it means our intention is to declare a variable as a pointer variable. But after the declaration, if I use this asterisk operator, this same operator, but the purpose is not same, because here it is known as dereferencing or indirection. Indirection means indirectly I will try to fetch the value pointed by the pointer. That's why it is known as dereferencing or indirection operator. So as soon as you write n3, you will get the value of num1. Why? Because this n3 holds the address of num1. That's why you are getting 9. Now, if you want, you can write asterisk n3 equal to 85. And if after this, I will try to print this num1, 100% you will get now 85. Because now you have to wage. Now you have to wage to change the value of the variable. Either you can give num1 equal to 85, or if you want you can write asterisk n3 equal to 85. Similarly, if I write again num1 equal to, maybe it is 65, if I print asterisk n3, then again it will fetch the value of num1 and you will get 65. So if you again print num1, you will get 65. It means we can change the value of num1 either with the help of num1 or with the help of indirection operator, but here we have to use the pointer, and the system will go to the location and fetch the value directly from there. Clear? Now I want to explain another program of this. What is this? So here I have written the name also, only to clarify so that you can remember it. What is this? A, B is a normal variable, asterisk C. I will go line by line, and if you have any doubt, again it is my request that you can write to me. I will try to give the answer as early as possible. A equal to 90, here you will get 90. What is this? C equal to address of A. It means now C is holding the address of A, so you will get address of A. But here if you write asterisk C, what is this? This is value of A. Here you have used this asterisk C. Asterisk C means the value of A. It means the value of B becomes what? Please tell me. The value of B becomes 90. Why? Because what is the meaning of this asterisk C? Asterisk C means the value of the variable pointed by the pointer C, and C is pointing A. So the value of A will be assigned in B. Again here asterisk C equal to 100, but here this A will become 100, but this B cannot be changed, it is 90. Here I have written again A equal to 120, so here also you will get 120. Now I have changed the value. What is the value? C equal to address of B. Okay, so you will get address of B, but now asterisk C means value of B, and what is the value of B? It is 90. Because from this point actually we have written C equal to address of B. It means now C is pointing variable B, and we will get the value of B here. Now B equal to 87. So please tell me what is the value of A. A is 120, no doubt, but B is 87, and asterisk C is again 87. It means with the help of dereferencing operator or indirection, if I want, I can change the value of the variable pointed by the pointer, or if I want, I can fetch the value also. Now we can try to execute it. What will be happen? Yes, error 0, warning 0. Try to run it. Here the same output you will get what I have shown here. Okay, so it is 90, 90, 90, 100, 90, 120. This is address, and this one. So I think In this to, today's class, we have discussed about the pointer, about the address operator, about the dereferencing or indirection operator. We will move further in our next tutorial of this pointer. Try to be with me in this entire discussion. It is very, very fruitful for your future as well as for your subject understanding power also, because this pointer is very, very important not only in C but in C++ also, or I can say that with the help of this chapter only we are able to understand the memory and this memory management of this system also. Thank you very much for attending my class, and please try to join me in my next tutorial of pointer that will be very, very fruitful. Thank you very much.